What did you do during the solar eclipse? Maybe you put on those glasses that you got from a gas station. Maybe you went outside and poked some holes in paper and held it against the sidewalk. I did that. It was pretty cool. But that being said, we knew that the solar eclipse was coming because we have science and whatnot. But animals have no idea that the solar eclipse is coming. So, how do they react when all of a sudden, out of nowhere, the daylight turns to nighttime? My name is Jake, by the way. This is my official face reveal. Ta-da! Anyways, today I want to talk about what animals do during a solar eclipse because I think it's an interesting topic and it's fascinating to look into what's going on with animals that have no idea that this is coming. First things first, just in case any of us don't know what a solar eclipse is, it's basically a brief period when the moon completely blocks the sun. The sky grows dim as twilight and temperatures can drop by several degrees in just minutes. For animals that tune their behavior to the regular cycle of day and night, this sudden fake night can trigger instinctive responses that are normally reserved for dusk or dawn, which means that during totality, daylight can drop to twilight or near complete darkness. Temperatures can fall several degrees in minutes, and wind patterns can change. Basically meaning that the sun's predictable daily rhythm gets suddenly interrupted. For animals, it's not just an illumination, it's information. Most species rely on photoperiod cues, which means changes in light intensity and duration tell them when to wake up, when to forage, when to vocalize, when to seek shelter, all those kind of things. But when daytime animals think that night has arrived, one of the most common observations during eclipses is diurnal animals behaving as if evening has arrived. So for birds, many bird species respond a little dramatically. Songbirds have been observed stopping daytime calls and later resuming singing as totality ends, similar to dawn choruses. Some birds fly back to roost midday. Zoo observations have recorded flamingos and penguins settling into nighttime postures. This suggests birds rely heavily on light thresholds, not clocks, to decide when day ends. Another diurnal animal that acts differently are insects. Insects are especially sensitive. Honeybees often return to the hive in mass during totality. Pollinators stop foraging abruptly. And as light returns, activity resumes almost immediately. The rapid shutdown shows how tightly insect behavior is linked to solar input. Part 2. Nighttime animals get the wrong signal. Interestingly, nocturnal animals don't always respond by becoming active. In some studies, owls and bats showed minimal or delayed response. Some animals did not emerge at all, possibly because the eclipse is too brief to trigger full nighttime behavior. This suggests that nocturnal animals may rely on multiple cues, not just darkness, but temperature, circadian hormones, and gradual sunset transitions. A sudden eclipse doesn't perfectly mimic night. As you can expect, when darkness happens in the middle of the day, not all animals switch to night mode. There can be confusion, stress, unusual behavior. For example, large mammals like giraffes and zebras have been seen pacing or clustering. Primates may vocalize or become alert. Reptiles sometimes seek shelter while others freeze. In zoos, it's been observed that some animals become unusually quiet, or some become more active than normal. Scientists think that this may be due to sensory conflict, darkness without the expected accompanying cues like cooling air or gradual sunset. One of the most fascinating aspects of eclipses is how they affect animals' soundscapes. During totality, crickets and frogs may begin nighttime choruses. Birdsong fades dramatically. The environment can become eerily silent. As sunlight returns, birds may sing as if it's morning again. Insects resume buzzing, and the soundscape reboots. NASA has a cool Eclipse soundscape project which records these shifts using microphones and citizen observers, allowing scientists to analyze behavioral patterns across regions. Sound, it turns out, may be one of the clearest indicators of how animals interpret eclipses. So, I've told you a bunch of reactions that can happen during eclipses, but why do these reactions vary so much? Not every animal reacts, and that's important. Factors that influence responses include sensitivity to light. This is probably why most nocturnal species don't react. Ecological niche, are they diurnal or nocturnal? So let's think about animals that evolved in environments with sudden darkness. such as dense forests or underwater habitats, may be less affected than open area species. This variation helps scientists understand how different species evolve to perceive time and environmental change. So why should we care about any of this? I mean, it's cool, but what are the actual implications? Solar eclipses act as natural experiments. They allow researchers to study circadian biology without artificial light manipulation. They allow scientists to compare instinctive versus learned behaviors, or observe stress response to sudden environmental shifts. Because eclipses are rare and brief, scientists rely heavily on citizen science, zoo observations, and cross-regional data collection. Each eclipse adds another piece to the puzzle of how animals experience their world. For a few minutes during a total solar eclipse, animals experience something deeply unnatural, a day that suddenly becomes night. Some respond instantly, some hesitate, some don't react at all. But together, these reactions reveal something profound. Animals don't just live in time, they live by it. And when the sun disappears, even briefly, the entire biological world has to decide what it means. If you enjoyed this deep dive into animal behavior, please consider subscribing. I'm trying to upload once a week for the entire year. And if you've ever witnessed animal reactions during eclipse, I'd love to hear what you saw. Thanks for watching, and I'll see you next time.